In this lesson, we're going to learn about variable expressions. Let's start by talking about what a variable is. Make sure you write this definition in your notes. A variable is a symbol, typically a letter, that is used to represent an unknown amount in a mathematical expression, equation, or inequality. Go ahead and press pause if you need more time to write down this definition. Now let's look at an example. Let's say I want to write the equation to represent 6 plus some number is equal to 18. Instead of using a blank or a box or a question mark to represent that unknown amount, I'm going to use a variable. So my equation will look something like this. 6 plus x equals 18. In this case, I've used the letter x as a variable that represents the unknown amount that's being added to 6. Now, let's talk about how variables can be used in different mathematical statements. To do that, we first need to talk about what those statements are. In math, we will be dealing with expressions, equations, and inequalities. An expression may contain numbers, variables, and exponents connected by operators, like the plus sign, subtraction, multiplication, or division sign. So some examples could be 5 plus 9, 12x minus 13, or 4x squared, which is an exponent. All of these are expressions because they contain numbers, variables, and or exponents that are connected by an operator. An equation, on the other hand, must contain two or more expressions that are connected by an equal sign. So the big difference between an expression and an equation is that an equation has an equal sign where an expression does not. So some examples of equations could be 5 plus 9 equals 14, 52 equals 12x minus 13, or 4x squared equals 2y times 3. You can see that all of these have mathematical expressions on either side of the equal sign. Finally, we'll also work with inequalities. An inequality must contain two or more expressions connected by an inequality sign. These can include greater than or less than, greater than or equal to, or less than or equal to, or not equal. So examples would be 5 plus 9 does not equal 17. 16 is less than 12x minus 13. Or 4x squared is greater than or equal to 2y times 3. Inequalities basically compare numbers instead of showing equivalency. So they don't say that one expression is equal to another expression. They're comparing two expressions by saying one is bigger, one is smaller, or they are not equal. For today's lesson, we're going to continue to focus on expressions. So let's look at how variable expressions are written. Make sure you copy this down in your notes. Variables can be used in expressions to represent an unknown amount. So here are some examples. I have 6 plus y. I can write the expression 6 with the operator sign for addition, and then the letter y, and this translates to 6 plus y. Make sure you have the highlighted words written down in your notes. You do not need to copy down the extra examples. For subtraction, if I have 15 less than m, that's going to be written as m minus 15, because I'm taking away 15 from the unknown amount that's represented by the letter m. 5 times a can be written in a couple different ways. We have 5 with the multiplication symbol that's an x or a dot, but you can also write 5 times a with just the letter 5 pushed next to the variable a. Whenever a variable follows a number, like in this example, we can know that they're just being multiplied. We just don't write the symbol between the number and the letter. For division, if we had b divided by 16, we could use our division sign. we could use a slash, but we could also write this as a fraction. We'll learn more about this later in our fraction unit, but fractions really represent division. So b over 16 is the same as b divided by 16. Go ahead and pause the video if you need more time to write these examples of variable expressions in your notes. All right, let's look at a few more examples. If I want to write 37 more than v, I know that I'm going to use addition because more than implies that I'm going to use addition. So I could write v plus 37 or 37 plus v. Addition can be moved around, so these expressions are the exact same. If I want to write 52 minus r, I would just need the number 52, the operator symbol for subtraction, and then the variable r. H multiplied 4 times could be written as h times 4 times 4 with a dot, or just 4h. Remember, a number and a variable squished next to each other means that they are being multiplied. And finally, let's look at some more examples for division. 12 divided by g could be written in these 3 ways. Remember, 12 over g is also the same as division, so we know that it reads 12 divided by g. All right, now it's your turn. You're going to write variable expressions for these 4 mathematical sentences. 6 times y, the sum of 72 and p, subtract j from 40, divide w by 20. All right, let's see how you did. For the first one, 6 times y, you could have written any of these 3 mathematical expressions. 6 times y with multiplication x, 6 times y with multiplication dot, or 6y. For the sum of 72 and p, you could have written 72 plus p, or p plus 72. When it's addition, it does not matter. For subtraction, order does matter, and you would have needed to write 40 minus j to show that you're subtracting j from 40. And finally, if we divide w by 20, you could have written w with the division sign, w slash 20, or w over 20.